All right, let's talk about plastic, the stuff that's absolutely everywhere. It's a genuine paradox, right? On one hand, it's this miracle material that shaped our modern world. On the other, it's a global scourge that just won't go away. But what if the solution wasn't just about using less? What if we found a way to actually unmake it? Let's get into it. First, let's just try to wrap our heads around the scale of this thing. Every year, we produce 400 million tons of brand new plastic. I mean, that's a number so big it's hard to even picture. So let's put it another way.
That's right. Imagine taking every single man, woman, and child on the planet and putting them on a giant scale. That's how much plastic we're churning out. Not once, every single year. And unlike us, it's designed to last forever.
So how did we end up living on a plastic planet? I mean, it's everywhere. To really understand the problem, we've got to look at what plastic actually is, and why the very thing that makes it so useful is also what makes it so dangerous. And what's wild is that it's not a million different types of plastic. It really comes down to just a handful of major players. Look at this. Over half of all plastic is either polyethylene, that's your plastic bags and shampoo bottles, or polypropylene, which you'll find in food containers or even car parts. Throw in PET from your water bottles and PVC, and you've basically covered most of the plastic we ever touch.
But here's where it gets tricky, because not all plastics are created equal. You've got two main families. On one side, you have thermoplastics. The easiest way to think about these is like butter. You can melt them down, reshape them, and they're good to go. That's what makes them recyclable. But on the other side, you have thermosets. These are more like cake batter. Once you bake it, it's done. A chemical change has happened that you can't undo. You can't unbake a cake, and you can't really recycle a thermoset. This one distinction is a huge piece of the puzzle. But you know, whether we're talking about a plastic bottle or some thermoset part, the big visible stuff is really only the beginning of the story. The really terrifying threat is the one we can't see. It's what happens when these materials start breaking apart in our environment and even inside our bodies.
Yeah, we're talking about microplastics. These are just what they sound like. Tiny, tiny fragments of plastic, often smaller than a single grain of rice. They are the invisible fallout from our plastic age.
So how does a grocery bag turn into a million microscopic threats? It all starts with the sun. UV radiation just hammers the plastic, attacking those long polymer chains that make it strong. The material gets brittle, fragile, and then all it takes is wind or waves in the ocean to just shatter it into smaller and smaller and smaller pieces. And the danger here is a double whammy. First, as this quote makes pretty clear, the chemicals in the plastics themselves are nasty. They're linked to things like cancer and major hormone disruption. But it gets worse. These tiny particles also act like little toxic sponges, soaking up other pollutants from the environment and then delivering that whole toxic cocktail straight into the food chain.
Okay, so faced with all of this, the answer we've all been sold for decades is simple, right? Just recycle, put it in the blue bin, and the problem's solved. But if it's that easy, why is everything getting so much worse? Well, the data tells a pretty brutal story. Just look at this. It's staggering. Of all the plastic humanity has ever produced, a whopping 79% of it is now sitting in a landfill or just loose in the environment. Only 9% has ever been recycled. Our recycling system isn't just broken, it's barely even working at all.
And here's why. It's just really, really hard to do. That little bit of food you left in a container, it can contaminate a whole batch. It's incredibly expensive to collect it, sort it, and clean it. And here's the real kicker. Most plastic isn't really recycled. It's downcycled. That water bottle doesn't become another water bottle. It becomes a park bench or carpet fiber. And then, that's it. It's the end of the line.
So, our big industrial approach has pretty much hit a brick wall. Our best technology has failed. So if our machines can't solve this, where on earth do we look for an answer? Maybe the solution isn't mechanical at all. Maybe it's biological.
And this is where the story gets really, really cool. Because it turns out, while we've been struggling, nature has been quietly getting to work. Scientists have found organisms that are actually evolving to clean up our own mess. Get this, isn't science fiction.
scientists are discovering real-life bacteria and fungi that have evolved the ability to literally eat plastic. The most famous one is Ideonella sakiensis. It was discovered in the gunk outside a recycling plant in Japan, and it can break down the PET used in water bottles. And as you can see, it's not alone. We're finding microbes that can digest the plastic in our shopping bags, our food containers, even our cars. It's evolution, happening right now in response to our pollution.
So how are they doing this? I mean, what's their secret? What kind of superpower lets you eat one of the most durable materials humans have ever created?
The answer is enzymes. The best way to think of them is like tiny biological molecular scissors. These microbes have evolved enzymes that are perfectly shaped to latch onto those long, complex plastic polymer chains and just snip them apart, one by one. They break the plastic all the way back down into its original, simple chemical building blocks.
And this is the absolute game changer. Remember downcycling, where plastic gets weaker each time? This is the opposite. This is true chemical recycling. By breaking plastic down to its fundamental components, its monomers, we can then use that raw material to create brand new, perfect, virgin quality plastic. We're not just reusing it, we're unmaking it and making it new again. It creates a truly circular system.
So this amazing discovery isn't just a cool thing happening in a lab. It's a powerful new tool. And it could be the engine that powers a whole new global strategy to finally end plastic pollution for good.
The United Nations Environment Program has laid out a roadmap that's actually pretty straightforward. First, reorient the market. Just get rid of the most harmful and unnecessary plastics. Second, reuse. Let's make reusable and refillable systems the norm again. Third, recycle. And this is where our enzymes come in, potentially making recycling profitable and truly circular. And finally, diversify. Let's invest in sustainable alternatives so we're not so dependent on plastic to begin with.
So, in the end, we're at a crossroads. The plastic paradox is that its greatest strength, its durability, is also its most fatal flaw. But now it seems like nature itself, through the incredible power of evolution, has handed us a blueprint for a way out, a way to create a truly circular plastic economy. The only question left is, are we going to be smart enough to build it?